In this video, I'm going to go over how to draw orbital diagrams. Orbital diagrams are a way to draw how electrons are arranged, and they kind of give a better picture of what's going on. So it's just an illustration of how electrons are arranged. Looking at this is one type of orbital diagram where they're drawn vertically. You can see that the 1s shell is at the bottom, and as you go up, the energy levels in the shells have more energy. This is the off-ball principle. It's why you fill up 1s before 2s, because 1s is at the lowest energy. And if you look right here, you can tell, now I'm probably not going to draw a very good straight line, 3D hits right there, 4s is right there, and yeah, my line is not very good. But 3D gets filled after 4s because it is at a slightly higher energy value than 4s is. So again, just throwing back to, in case you forgot, an orbital is where two electrons are found. The S has one orbital and it's spherical shaped. P has three orbitals and they've got different orientations. They're kind of dumbbell shaped. D has 5 orbitals and F has 7 orbitals. That's why we say it's F14, because there are 7 orbitals, each can hold 2 electrons. And so when you look at an orbital diagram, this line right there, that represents an orbital. And so we've got 2 electrons in one S. Each electron is represented by the arrow. So the arrow represents an electron. P has 3 orbitals. That's why there's 3 lines drawn, 1 for each orbital. And each orbital has 2 electrons in it. So you've gone over the off-ball principle before, but if you haven't heard of it, it is electrons fill orbitals at the lowest energy first, which is why you fill 1s all the way up to 5f, and you go in that order. And that is why 3D fills after 4s, because it's at a higher energy level. Hund's rule really applies to drawing orbital diagrams. I mean, it applies to electron configurations, but you can't see it. But when you draw orbital diagrams, you have to follow Hund's rule, which is when you're filling equal energy orbitals, so like when you're filling 2p, electrons arrange themselves to maximize unpaired electrons. So looking at this is a correct orbital diagram. 2p, where there's 2p has 3 electrons, or 3 arrows, and each arrow is in its own orbital. This is how they fill up 2p. They each go in their own orbital first. This one would be wrong, because there's an open orbital. This electron right here should be in there. So they each fill up an orbital, and then they double up or add to a second electron to an orbital when they have to. So let's say if it was 2p4 and I was drawing this orbital diagram. 1, 2, 3, and then the 4th one would go here. Because there's no more orbitals, then you double up. If I wanted to draw a 2p5, now I would add the second one to this orbital. But the electrons fill orbitals that are empty first before doubling up. That's Hund's rule. And then the reason why the arrows get drawn one up, one down is the Pauli exclusion principle. And this has to do with quantum numbers, which is really out of the scope of 10th grade chemistry, what you need to know. But in an orbital, you have 2 electrons and they have to have opposite spins. It has to do with the magnetic fields that is created. They are opposite of one another. And again, this can get extremely complicated. Quantum mechanics. They have opposite spins, create opposite magnetic fields, and they're drawn one up, one down, not like this. If you were to write the orbital numbers, this would be different because one is up, one is down. These two would have the exact same quantum numbers, which can't and does not happen. But again, it's kind of out of the scope of this class. So Hund's rule, you fill up one orbital at a time in a sublevel. So 2p, you fill up boom, 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 and then you start doubling. And the Pauli rule is when you have 2 electrons in one orbital, or like in one of these, one is up, one is down, because they have to have opposite spins. So we're going to draw some orbital diagrams for you to practice. The first one is oxygen, right here, number 8. It might help if you're not that comfortable writing configurations. Let's write our configurations first before we start drawing. So oxygen has 8 electrons. First we fill up 1s2, so boom, boom, 1s2, and then after number 2 you go to 3 and 4 right here. That is 2s, and it's full because we're not at oxygen yet, so 2s2, and then over here to 2p, because this is the p block, and oxygen is 2p, 1, 2, 3, 4, 2p4. And so how I would draw this, I'm going to represent my 1s orbital. 1s only has one orbital, so one line, and I write 1s underneath it, and it's got 2 electrons in it, one arrow up, one arrow down. And then 2s. 2s has one orbital, and I'm going to write a 2s underneath it, one arrow up, one arrow down, because it has 2 electrons in it. Now p. P has 3 orbitals, so I'm going to change colors. I'm going to draw 3 orbitals, 1, 2, 3, and label them 2p. And then for p, we follow Hund's rule, fill up 1, 2, 3, and then the 4th one goes down in the first one. And so that would be the orbital diagram for oxygen. Now you can draw orbital diagrams like this in a line, or you can draw them like this vertically. Either way is correct, and you could boom, boom, so forth. The way I did it's probably easier. Okay. Next we're going to draw it for sodium, down here number 11. So pause the video. I want you to try and write this configuration and then draw the orbital diagram. So hopefully that is what you drew, and your configuration was 1s2, 2s2, 2p6, 3s1. Nitrogen. Pause the video again, and then when you hit play, I'm going to draw it for you to check. Okay, so 1s is full with nitrogen, 2s is full, and nitrogen ends on 2p3. So 1, 2, and a 3. And that's it for drawing orbital diagrams. There's not a ton to it. They're pretty simple. There's no shortcut for orbital diagrams. So let's say you were asked to draw the orbital diagram of Mercury down here. You would just be, drawing a lot of arrows. But that's okay.